So hi everyone. So today let's continue our lecture, which is about the line integral of scalar field, and we focus on the piecewise smooth curve. So you can refer to page 148 of your module. Okay, so this is line integral of scalar field. Okay, we focus on the piecewise CE. Okay, piecewise smooth curve. Okay, so the difference between this one and the previous one is you will see the curve will be broken into several sections. Okay, so you have to solve the line integral for each of the section one by one. So you have example 4.15. You can have a look at yourself. I want to go to the example behind. Okay, there is page 152. Okay, question number 6A. Okay, question number 6A. So you have to evaluate the line integral, okay, y dx minus x dy. Okay, so this is the line integral that you have to solve, and along the curve shown in the figure A. Okay, we focus on the figure A. So if you look at figure A, okay, so this is the figure A. So this is your axis y, this is your axis x. Okay, you can sort like see the triangle. Okay, right, there's a triangle, right? Okay, so this one represent your curve. Okay, so this is your curve. We have the C1 curve, the C2 curve, and C3 curve. Okay, so the C over here is a combination of C1 plus C2 and plus C3. Okay, so this is what I mean that you break the curve into different sections. Okay, so what you have to do is will be the same. Okay, it will be the same like what you have tried, okay, last week. Okay, but now you have to find the answer for the each of the curve, and then you add them together. Okay, so the answer will be the summations of the line integral from C1, okay, line integral from C2, and line integral from C3. Okay, you have to add them together in order to get the answer, okay, for the total line integral. Okay, so we go to the first curve, that is a C1. Okay, so C1 is a point that is from 0, 1 to 0, 0. Okay, 0, 1 to 0, 0. So basically you can see that the x okay, remain 0. You can see the x, right, remain 0, but the y, okay, is from 1 to 0. Okay, so now you have to decide whether you want to convert the whole line integral to x dx or y dy, y dy, okay, or t dt. Okay, so here personally I will choose this one, okay, because this one is easier, okay, compared to this one. Okay, and I don't pick this one also, okay, because the x remains 0, so I won't convert it to the x. Okay, so I'll pick the second option. So we look at our line integrals again. Okay, so this is line integral. You have the y dx minus x dy. Okay, so you want to convert it to y dy. Okay, so you need to replace the dx and also the x. Okay, so in this case, okay, you know your x is equal to 0, so the dx automatically becomes 0 as well. Okay, so for the C1, okay, this is the C1, y will remain, okay, dx will be 0 minus, okay, x is 0, dy will remain. Okay, so in this case, you will see that the answer is equal to 0. Okay, so the line integral for path C1 is equal to 0. Okay, right. So we look at the path C2. Okay, path C2. So where is C2? Okay, C2 is from 0, 0 until 1, 0. Okay, so I will write down C2 is from 0, 0 to 1, 0. Okay, so basically you can see that your y is 0 and your x is from 0 to 1. 0 to 1. This is your x. Okay, 0 to 1. So again, I want to convert my line integrals, okay, from C2. Okay, so this one is dx minus x dy. So I will choose to convert it into the x dx. Okay, so similar like the previous one, when the y is 0, okay, the dy is also 0, right? So y is 0, dy is also 0, so this gives you answer 0 as well. Okay, we go to the path C3. Okay, let's see where is path C3. C3 is from 1, 0 to 0, 1, and it is linked by this straight line. Okay, 1, 0 to 0, 1. So you can see the x is changing from 1 to 0. Y is changing from 0 to 1. Okay, so you have to pick whether you want to convert it into the x dx or y dy. Okay, just pick one. Any will do. Okay, it can be this one, it can also be this one. Okay, so in order to convert it into the x dx or y dy, we need to find out what is the relationship between the x and y. Am I right? So these 2 points, they are linked. Okay, they are joined together by a straight line. Am I right? Okay, straight line. So the straight line has the equation y equals to mx plus c. And in this case, your m is equals to negative, okay, 1. Okay, and the intersection point is equals to 1 as well. Okay, so when you write down the equation for the straight line, it will be negative x plus 1. Okay, so now you see the relationship between the y and also the x. So in case I want to convert it into the dx, okay, for example, I just pick one. I want to convert it into this one. Okay, so I will calculate what is my dy dx. Okay, it will be negative 1. And my dy will be negative dx. Okay, so when I know this thing, okay, look at this integral. I'm going to replace it here. So all the y will become negative x plus 1. Okay, dx remain. Okay, x remain. And dy will become negative dx. Okay, just replace it. Okay, and the interval, you will following the interval of the x, which is from 1 to 0 here. Okay, 1 to 0. So 1 to 0. Okay, so if you simplify again, 1, 0, negative x plus 1, and this is plus x dx. Okay, you can basically cancel it. Okay, so this one will give you negative 1, right? Okay, this one will give you negative 1. Okay, so to find the total line integral, it will be the summation of C1 plus C2 and plus C3. Okay, it is 0 plus 0 and plus negative 1. Okay, so the answer is equals to negative 1. Okay, so this is the line integral of scalar scale. Okay, and we focus on the piecewise smooth curve. Okay, so basically you just split your curve into different sections, okay, as indicated by the questions. Okay, now we move on to the next one, okay, which is the line integral of scalar field in space. So this is a line integral of scalar field in space. Okay, in space, you can refer to page 150 of your module, page 150 of your module. Okay, so the difference case will be the wording of here in space. Okay, in space here meaning that it will be 3D. Okay, the curve will exist in 3D. Okay, just like in the example 4.17, you can have a look at the example 4.17. Okay, but here now I want to look at a different example. Okay, that is the example behind. Okay, question 9. Okay, page 153. Question 9 here. So calculate the line integral. Okay, this is your line integral. So you have an x squared z dx minus yx squared dy plus 3 dz. Okay, so now you see you will have a new component that is the z and dz because it is 3D. 3D. So you need to evaluate this thing, and the path is given like in the drawing. Okay, so you have to draw 3D. Draw 3D. So the first one is C1. C1 start from the origin and stop at 1 here. And then it move in the y directions and stop here. Okay, and this point is actually, in fact, it is equals to 1. And then move up and stop here. Okay, this is a path C3. Okay, so the height over here will be 1. 1. Okay, will be 1 also. Okay. Now you have 3 paths. Okay, just like the previous one. You have a C1, C2, and also C3. In order to find the total line integral, okay, you have to find the line integral of C1, C2, and C3. Okay, very similar to the previous example. We'll look at path C1. Okay, so path C1 is over here. Right, it is from 0, 0, 0 and to 1, 0, 0. So when you compare, you will see that your y is equal to 0, z is also equal to 0. Okay, and your x is from 0 to 1. Okay, so I decided to convert it all to the x dx. Okay, I want to convert it to x dx. Okay, which means that I need to find what is dy and what is dz. So for this case, both of them, they are 0. Okay, so when we replace it in the line integral, okay, you have x squared z dx minus y x squared dy plus 3 dz. Let's see what you can get. Okay, the y, dy 0, dz 0, right? And the z is also 0. Okay, so making it to become 0. So the line integral of path C1 is 0. Okay, so we move on to path C2. So path C2 is from, oh sorry, I get the wrong label. This will be y, this will be x. Okay, so C2 will be from 1, 0, 0 to 1, 1, 0. Okay, you can see that it is from 1, 0, 0 to 1, 1, 0. Okay, you can see your x is equal to 1. Okay, your x is equal to 1, it's not 0. And your y is from 0 to 1. And your z remains 0. Okay, we follow the same procedure, finding the dx. which is equals to 0. Okay, and the dz is also equals to 0 because I want to convert it into the y dy. Okay, I want to convert it into the y dy. So we replace it. Okay, we replace it. So we cancel what is 0. This is 0. Dx is also 0. Okay, but this is not, the second term is not 0. Okay, the second term is not 0. So now we can calculate the second term. We put the interval, we put the y, and the x in this case is equals to 1. 1 square dy. Right, so now you can press calculator to find the answer for this. So negative x, so you have 1 and 0, so you get negative 1 over 2. Okay, so this is the line integral for the path 2. Okay, we move on to the line integral for the path 3, C3. Okay, C3, what is C3? You can see the C3, C3, C3. C3 is from 110 to 111. Okay, 110 to 111, 110 to 111. Okay, so x remain 1, y remain 1, and the z is from 0 to 1. Okay, so here the dx will be 0, dy will be 0. Do you know why it is 0? Because there is no variable for you to differentiate, right? Okay, it is a constant. When you differentiate, it will be 0. So I'm going to change it to z dz. Okay, so I copy here again. Dx is 0. Okay, dy is also 0, and this one remain is not 0. So we can calculate 0 to 1, so 3 dz. So the answer is equals to 3, right? So now let's find the total. It will be 0, okay, plus negative 1 over 2, and plus 3. So you get 2.5, okay, as the answer for the line integral. Okay, so this is happens, okay, for the line integral of scalar field in space, in 3D. Right, that's all for today. Thank you.